In this video, we're going to talk about equivalent fractions. But first, let's review something. 1 can be written many ways. 5 over 5 is equal to 1. 7 over 7 is equal to 1. 2/3 divided by 2/3 is equal to 1. 13 over 13 is equal to 1. 8 over 8 is 1. 0.7 divided by 0.7 is 1. As long as the top and the bottom are the same and they're not 0, because you can't divide by 0. Here we're dividing by 5, and here 7, and here 2/3, and over here 13 and 8 and 0.7. We're not dividing by 0 in any of these. And since the top and the bottom are the same, the top and the bottom are the same, they're same, they're same, it always equals to 1. Now, suppose you were asked to fill in the box. 1/2 is equal to what number over 10? Well, basically, can do it this way: 2, 4, 6, 8, 10. And you always get 1 out of 2. So let's partition them into 2's. 1 out of 2. You got that one right. You got that one right. On these 2 basketball shots, you got that one right. 2 exam questions, you got 1 right, 1 right. So you got 1, 2, 3, 4, 5 right. That's one way of doing it. Another way is to realize that you can always change the way something looks by multiplying it by 1. 1/2. Now, whether you write everything I'm going to say, that's up to you, but you should think it. 1/2 is equal to 1/2 times 1. Doubt anyone would disagree with that. And this is going to equal to 1/2 times this, and it's going to be a fraction, as long as this is 1. Well, I want to get a 10 in the bottom. 2 times 5 will give me 10. Now, if this is going to be 1, like every other fraction, the top to be that equals 1. The top and the bottom have to be the same. The bottom's 5, the top has to be 5. 1 times 5 is 5. These 2 fractions are equivalent. That just means they're equal. If you have 3 over 7 and you want to write it down as some number over 28, you want to change the way 3 over 7 looks. So you take 3 over 7 times 1. And I want to end up with a 28 on the bottom. So it should be a fraction. 7 times 4 gives you 28. And if this has any hopes of being 4, the top has to be the same as the bottom. 3 times 4 is 12. Got it. I wrote 3 over 7 equals 27 over 28. Sorry, 12 over 28. Okay, so I wrote 3 over 4 with an 28 in the denominator. Suppose I want to write 3 over 5 with 30 in the bottom. Now you can ask yourself, what do you multiply 5 by to get 30? The answer is 6. Well, you're going to have to multiply the top by 6 as well. Basically, that's just shorthand for saying this number equals itself times 1. Now I'm going to write the 1 as 6 over 6 because 5 times 6 gives me what I want, which is 30. And 3 times 6 is 18. So the unknown number is 18. Suppose you had 8 divided by 21, and you want to represent it as something over 42. If you want to change the way a number looks like, just take that number and multiply it by 1. I would multiply, oh, it's supposed to be 21, sorry. I would multiply by 2 over 2. Not because 8 times 2 is 16, but because 21 times 2 is 42. And that's what I want. 16 over 22. These two fractions, this one and this one, are equivalent. This one and this one are equivalent. It's just a fancy word for saying equal. 3 over 2 is equal to 6 over what number? Well, just work it out. It's definitely looking different because the numerator went from 3 to 6. How can it look the same? If it doesn't look the same, you multiply by 1. And since I want a 2 on the top, and since 3 times 2 is 6, I'm going to put a 2 on the bottom. Because of that 2? No, because 2 over 2 is 1. And 2 times 2 is 4. So it's 6 over 4. If you had 14 over 3, and you want to write this as 42 over some number, you take 14 over 3, it equals itself times 1. And somehow you want to get a 42 on the top. So you're going to multiply by a fraction. 14 times 3 is 42. So you have to multiply the bottom by 3 as well. It's a coincidence that's 3. 3 times 3 is 9. 42 divided by 9. If you have 3 over 4 and you want to know that's the same as 9 divided by, what divided by 32? It's simple. You want to change the way 3 over 4 looks like. That means you multiply by 1. Since we're multiplying, the first number is a fraction, and you want to get a fraction, maybe you should multiply by a fraction. But that fraction has to be 1. 4 times 8 gives you 32. So you have to multiply the top by 8. Because otherwise, you're taking 3/4 and you're multiplying by other than 1. In this box is only going to be 1 is if you put 8 over 8. You can also put 7 over 7, but the problem is this 4 times 7 won't give you 32. So we're going to multiply by 8 over 8. 8 times 3 is 24, and yep, 4 times 8 is 32. So it is 24 divided by 32. So as long as the two fractions are equal, it's known as equivalent fractions. 10 over 15, 17, how about 12? 12 over 18. The question is equivalent or not? Okay, is that equal sign valid or not? Well, there's really two ways of doing it. You can divide each fraction separately. 5 goes into both of these numbers 2 and 3 times. And those two numbers are on the 6 table. Divide by 6 then. And look at this. I get 2 over 3. So yes, they're equivalent. Another way of doing it is, if you have 10 over 15 is equal to 12 over 18 is, you can multiply those two numbers and multiply those two numbers. 18 times 10, does it equal to 12 times 15? Well, the left side is 180, and the right side, yeah, it's 180. So yes, they are equivalent, because they're equal. How about 15 over 20 equals 21 over 28? Is that equal? Well, 5 goes into both of these numbers 3 and 4 times. 7 goes into both of those numbers 3 and 4 times. So they both equal 3/4. Equivalent. If you have 6 over 35 and you want to know if it equals to 18 over 105. Now, just for the record, back to the last one, if you wanted to, you could have multiplied those two numbers. 28 times 15, does it equal to 21 times 20? 14, sorry. Yeah, this should be 420, and yeah, that's 420. So yes, equivalent. Two different ways. Here, you can divide this number by 3, and you can divide this number by 3. You don't have to divide by, oh, that's the only thing you can divide by. Okay, and we got this equals that. That's good. Again, an alternative way is, if you have 6 over 35 is equal to 18 over 105, you can multiply those two numbers and see if you get the same as multiplying those two numbers. Well, 6 times 100 is 600. 6 times 30 is 30. 600 plus 30 is 600. Well, let's see. I hate multiplying the number. I usually don't multiply the numbers that are given. If I double the first number and I half the second number, well, 7 times 9 is 63 with another 0. This product is the same as this product. If you have A times B, so I changed the way it looks. It used to look like 35 times 18. Now it looks like 10 times 19. 10 times 9. Okay, what I'm doing is I multiply by 1. And the way I want to write the 1 is 2 times a half times A times B. And I am now multiplying 4 numbers. I can multiply in the order I like. I like to multiply the 2 and the A first. Then I'm going to multiply the half by the A, which is the same as A over 2. One slight error. That second number is B. I apologize. A times B. A times B. I multiply the A by 2. There it is. I multiply the B by a half, or I divide by 2. So instead of doing A times B, I can double A and half B. In fact, this is equal to 1 times AB, 1 times AB, and 1 is any number times its reciprocal. Maybe 7 and 1/7, maybe 3 and 1/3 times AB. I can multiply the k by the a, and I can multiply the b by 1 over k, which means I divide. I can multiply this a by any number I like, as long as I divide b by that same number. Okay? If somebody asked me what, say, 400 times 8 is, no, I can divide this by 4, and I can multiply this one by 4. So this gives me 100, and that gives me 32. So the answer is 3,200. Answer is 3,200. If you asked me what 25 times 28 is, this is a very simple problem for me, because if I multiply the 25 by 4 times, and I divide the 28 by 4, I get two nice numbers, 100 times 7. And I know what 100 times 7 is. That's a nice little trick. Good, big enough trick, or good enough trick for me to show it here. Okay. So we are back to, are they equivalent or not? Do a couple more. Suppose you have 7 over 2 and 48 over 7. Well, you can't reduce any of them. You can't reduce this fraction, because 2 doesn't, the only number that goes into 2 is 2, and it doesn't go into 7. You may say, well, 1 goes into 2, but as we did once before, if you divide both of these numbers by 1, you get back the same fraction. So dividing by 1 isn't helpful. And in this fraction, can't divide by 1 either. So you multiply the 7 and the 7, and you multiply the 2 and the 4. Now, let's just make it a little bit closer. I really meant for that to be 24. And once again, you can't reduce the 24 over 7. Okay. This turns out to be 49. This turns out to be 48. They're pretty close, but they're not equal. So this wasn't equal. So the original two were not equal. Equivalent or not, this one's not equivalent. Suppose you have the following fraction. 2 over 5 versus 5 over 12. Can't reduce it. Multiply those two numbers, get 24. Multiply these two numbers, get 25. 24 does not equal 25, so 2/5 does not equal 5 over 12. Since these numbers are close to one another, these fractions are close to one another. If you were to do 5 into 2, you get 0.4. If you did 12 into 5, put down some zeros. 12 goes into 54 times. They used up 48 with 2 left over. Bring down a 0. 20 goes into 12 one time. 12 goes into 21 times with 8 left over. Bring down the 0. 12 into 80 goes 6 times, that's 72. Oops, with 8 left over. Bring down to 0. 12 still goes into 80 6 times. Used up 72 with 8 left over. Okay, but basically, this 6 is going to keep repeating. But as I promised, they're not equal, but they're close. You know, if this were 11 equal 25, then the fractions will be very far away. For example, I had 7 halves initially and 48 sevenths. You should know that this is a round 7. You know, if this was 49 instead, we would get 7. So it's a little bit less than 7. This is only 3.5. Of course they're not equal. And they're far apart. This is 3.5. This is approximately 7. In fact, this is about double 3.5. Now if you cross multiply it, 7 times 7 is 49. And 2 times 49 is 96. Notice it's almost 2 times larger. 49 times 2 is 98. Just like this number was almost double that number. So that ratio will stay the same. So try one more. You have 3 over 5th versus 5 over 8. So you should think, are they somewhat equal? Well, 2.5 over 5 is a half. 4 over 8 is a half. This is a little bit more than 2.5. This is a little bit more than 4. There's a shot that they'll be equal. If not, they'll be close. 8 times 3 is 24. 5 times 5 is 25. They're not equal. But since those numbers were rather close, these numbers are rather close. And this fraction will be larger than this fraction. The fraction that used the 5 was larger. The fraction that used the 3 was lower. The 3 times 8, the product that used the 3 was the 24, and the product that used that numerator was 25. This product used the numerator 3, this product used the numerator 5. Since that number is bigger than that number, the fraction that used the 5 is larger. This fraction is larger than this fraction. This completes this section on equivalent fractions.